In this lesson, we're going to write line equations starting with parallel or perpendicular lines. So we're going to quickly review a couple properties here. Parallel lines have the same slope. So if you're going to write a line equation and you want to write the equation of a line parallel to another one, the new slope, or the parallel slope, is going to be equal to the original slope. Now that's not true for perpendicular lines. Perpendicular lines have slopes that are negative reciprocals. So if you want the slope of a line perpendicular to another line, you've got to take the original slope. The perpendicular slope is the negative reciprocal of the original slope. So we're going to write down some steps to write line equations when I want to write them parallel or perpendicular to another line. The first thing you need to do, if it's not done already, is to place your original equation, your original function, into y equals mx plus b form. So you got to solve for y if it's not already solved. And then you need to identify the slope in that formula. Now the slope is going to be the coefficient in front of the variable. So m is going to be the slope. Now if you're trying to write the equation of a line that's parallel to the original, then you're going to keep the slope and you're going to use it with your new information. But if you want a perpendicular line, you need to use the negative reciprocal of this slope. You reciprocate it, so you flip it and then you change the sign. So then you would take your new information, which would be your slope and whatever else you're given, probably a point, and you're going to substitute it into y equals mx plus b, find a value for b, and then write your new equation. And that's the basic process. So now we'll work through some examples to show you how to do this. Write the equation of a line passing through negative 2, 3 and perpendicular to this line. So I have a point that I can use, but now I need to find the slope. The slope of the original line, since it's already solved for y, is 2. So the original slope is 2. I need to find the perpendicular slope. So the perpendicular slope is going to be the negative reciprocal. I flip it and I change the sign. So I need to use negative 1/2. Now I just substitute in. I have a y value and an x value, and I have the slope. So 3 is equal to negative 1/2 times negative 2 plus b, because we're always substituting into y equals mx plus b. Alright, 3 is equal to, when I multiply negative 1/2 by negative 2, I get positive 1. So b is going to be 2. Now I just put everything together. Y is equal to negative 1/2 x plus 2. Okay, so the slope comes from the fact that my new line is perpendicular to this one. So the 2 is flipped and changed in sign. And then I don't keep the 5. I got to solve. The 2 comes from solving for b. I take the x and the y and I substitute them in, and I find a value for b for my new line. Okay, let's look at the second one. Write the equation of a line parallel to 3x plus 2y is equal to 6, passing through 8, negative 5. So again, here's my new x and my new y, but I have to find the slope. I'm going to take the 3x plus 2y, and I'm going to solve for y. So I subtract 3x, I get 2y is equal to negative 3x plus 6, and then if I divide each term by 2, I get y is equal to negative 3/2 x plus 3. The only thing I care about is this slope. And since it's parallel, I'm going to keep that slope. So my new slope is going to be negative 3/2. So now I substitute all my new information into y equals mx plus b. So negative 5 is equal to negative 3/2 times 8 plus b. Negative 5 is equal to negative 12, I think, plus b. So b is going to be positive 7. I got to write my final line equation though, so my final answer is y is equal to negative 3/2 x plus 7. So once you find the value of b, you still have to write your final equation. Okay, the next one is a more standard problem. I have 2 points, so if I'm going to find the line equation, I have to calculate the slope first, x2 and y2, and then choose one of those points to put it into y equals mx plus b. So let's find the slope. The slope is going to be 7 minus a negative 2 over 3 minus 5. So that's going to be 9 over negative 2. So negative 9/2. I'm going to keep that slope, and I'm going to substitute in and find a value for b. I can choose either one of these coordinates here. So I think I'm going to use this one because it happens to be all positive. 7 is equal to negative, this is negative 4.5 times 3 plus b. So 7 is equal to negative 13.5 plus b. So b is going to be 20.5. So my final answer is what I get when I put everything together. Y is equal to negative 4.5x plus 20.5. I'm not always going to have whole numbers for my answers because functions can be anything really. So you do have to remember that. All right, the next example, which is, and then, yeah, we'll do 2 more. So the next example, write the equation of the line perpendicular to the line example 3. So perpendicular to this one, passing through 18.4. Well, I need to write this as a fraction so I can write the perpendicular slope. So the fraction is negative 9/2. So if my original slope is negative 9/2, my perpendicular slope is going to be positive 2 over 9. And passing through 18.4, there's x, there's y, so 4 is equal to 2 over 9 times 18 plus b. 4 is going to be equal to 4 plus b. It looks like b is going to be 0 this time. So y is equal to 2 over 9x. So that's how you do that one. The final one here, write the line of the equation, or write the equation of the line perpendicular to y equals 3 and passing through 2, 4. Y equals 3, that is a horizontal line. So y equals 3 is here. Perpendicular to y equals 3 would be an x equals equation. If it's passing through 2, 4, here's my x value, here's my y value. That means x has to be equal to 2. So that's my new line equation. X is equal to 2. So we're going to practice a lot more of these examples, particularly the ones on the last page. We're going to do all of that in class.